So we've learned two multiplication rules for the vectors, right? One is the dot product, and we can write this as the U dot V is going to be a constant, and we can calculate this by multiplying the components, corresponding components of the vectors, right, to each other, and add them at the end, right? So, and the cross product is another type of the product for the three-dimensional vectors, and it has a huge formula, right? So here, let's discuss a little bit what is the difference of the dot product and the cross product geometrically, okay? So let's say we're given two vectors, u and v, and there is an angle between them, okay? So we've got a formula that u dot v divided to the norm of the u multiplied to the norm of the v is equal to the cosine of the angle between these two vectors, right? So from here, we can write down that the u dot v is actually equal to the u multiplied to the v multiplied to the cosine of the angle, right? Yes? Okay. So now, if we're given the two vectors and if we're given an angle between them, let's create the right angle triangle, okay, like this. So that the angle is going to be here right angle, okay? So what do you think? What is so from the right angle triangle, I know that if we multiply the adjacent side to the, so adjacent side V can be found by multiplying the cosine of the alpha to the hypotenuse of the triangle, right? So adjacent side on this side, right? This is not V, please note, right? Because V is bigger, longer, at least in this example, right? So exactly this side of the triangle is called the adjacent side of the triangle, adjacent side. And this is not the norm, this is not the length of the vector V, right? Because the length of the vector V is longer in this case, right? So this adjacent side can be found by multiplying the length of the hypotenuse, right? Multiplied to what? To the cosine of the angle between them, right? So yesterday, actually, we talked about this adjacent side, right? We said, hey, if we're given two vectors, u and v, if we project the u onto the v, we're going to have this vector. And actually, the adjacent side of this triangle is the length of this vector, right? Okay, so u norm multiplied to the cosine of alpha is actually equal to the adjacent side of this triangle, right? And if I substitute the u multiplied to the cosine of alpha in the formula of the dot product, what I'm going to get is u dot v is equal to the norm of the v, right, multiplied to the adjacent side of the triangle. Okay, this gives us some feeling about what is a dot product, right? So dot product measures this length. So you multiply the length of the vector v to the length of the projection, right? So this is the meaning of the u dot v. Do you feel this? Okay. Okay. So that is why when we talk about the perpendicular vectors, so let's say we're given a vector v and vector u, which are perpendicular, right? So if they're perpendicular, if you multiply the u to the dot v, this is going to be, we said, okay, so u dot v can be found using this formula, right? Or we can find a u dot v using this formula, or we can find a u dot v using this formula. So all of these formulas help us to understand what is the dot product, okay? So using the last formula, we say that if you multiply u to the v as a dot product, this is going to be the length of the vector v multiplied to the length of the projection of the vector u onto the v, right? So if these two vectors are perpendicular, what is going to be the projection of the vector u onto the v? It's going to be 0, 1 point, right? And the length of the 1 point is equal to the 0. And this is going to be the norm of the v multiplied to the 0 is equal to the 0. Okay? So this is just a discussion session where we'd like to discuss what is a dot product and try to understand what is a dot product a little bit more deeply. Okay? So now let's talk about the cross product. So this is the v, and this is the u. So first of all, do you remember we defined a cross product as what we wanted to do from the cross product is to obtain a third vector which is going to be perpendicular to both of the vectors, right? This is the first thing which we know about the cross product, right? So if you multiply u to the omega, it is going to be 0, or v to the omega, it's going to be also equal to the 0, right? This is the definition of the cross product. So we would like to create a vector omega, which is going to be perpendicular to both of the vectors. So that is why we've got this big formula, right? This is going to be a determinant of the matrix, which we're going to obtain by putting the I, j, k vectors on the first row, right? Then components of the vector u on the second row, and the components of the vector v on the third row. At the same time, we talk about the formula for the cross product. Do you remember the cross? So this is the cross product of the u to the v, right? So do you remember we've talked about the formula cross product of the u to the v, and its norm is equal to the norm of the u multiplied to the norm of the v multiplied to the sine of the angle between them, right? Okay, so let's say we're given an angle between these two vectors, okay? If I create again the right angle triangle here, right? Now what I want to do is I would like to find the length of the side. Opposite side, right? Do you remember we call this as the opposite side? Is it possible to find the length of the opposite side from the right triangle? From this one? So the opposite side is going to be equal to the hypotenuse, or the length of the hypotenuse, right? So this is going to be the length of the u vector multiplied to what? To the sine of alpha, right? So now we can substitute u multiplied to the sine of alpha here, and we can get some intuition about the cross product, right? So the cross product u multiplied to the v and its norm is going to be equal to the length of this vector v multiplied to what? Multiplied to the opposite side, right? Actually, when we're doing this projection, this is going to be the length of this vector, right? So you're projecting vector u to the v. If you multiply the length of the projection onto the length of the vector v, this is going to be equal to the dot product, right? If you multiply the length of the vector v onto the length of this vector, green vector, this is going to give you the length of the cross product, right? Because the cross product is the vector, and we're talking about the length of the cross product, right? So we can find the length of the cross product using this formula as well. So in order to do this, we need to multiply the second vector, the length of the second vector, to this opposite side, okay? So we talk about these vectors, right? And let's consider two vectors which are parallel, okay? This is going to be one vector, u, and another vector, v, on the top of this, right? Because when we talk about the position vectors, this is the only way to draw the parallel vectors, right? Because if they start from the same point, the parallel vectors are going to be on top of the other, right? Okay, so what I need to do is, in order to find the cross product, using this definition, I need to multiply the cross product u to the v and its length is equal to what? To the norm of the v, right? Multiplied to the length of this vector, which is when we project the vector u onto the v, right? So when you project the vector u onto the v, what kind of vector you're going to have? This vector, this kind of vector. When you project the u onto the v, right? If they're parallel, this vector is going to be, the length of this vector is going to be equal to the 0, right? Because they are on the same line. Do you understand this? Yes? So according to this definition, so the length of the cross product is going to be equal to the length of the vector v, the vector where we are projecting, right? Multiply to the length of this vector, okay? So in this case, when the two vectors are parallel, this is going to be the length of the vector v multiplied to the projection, this vector, when we project the vector u onto the v, and this vector is simply 0 because they are on the same line, right? And its length is equal to the 0, so that is why it is going to be equal to the 0. Okay, so this is a little bit more intuition about the difference between the dot product and the cross product geometrically.